Another example, it is given that suppose this is a sphere made up of some transparent material whose refractive index is √3, that is given. This is center, like this. Now light ray is incident here at angle 60 degree, this is given, and then as it is going into denser medium, because here it is air, so it will bend towards normal. This is normal here, and then get incident at this point, so this will be normal here, and finally it emerges out from the sphere. This is normal. Let this whole angle be angle of emergence, E. This angle is R1, angle of refraction at first surface. Let this angle be R2, and this whole angle is E. Then first find R1, R2 and angle of emergence E. Second, also find total deviation. This we have to find. So first, refraction at first surface, at first point. This is second point. Refraction at first point. Apply Snell's law here. Mu air into sine 60 is equal to mu into sine R1. Refractive index of this medium I am taking mu. So it is 1 into √3/2 is equal to √3 sine R1. So √3 cancel. Sine R1 is 1/2. So R1 is 30 degree. So R1 is now known to us. Now you know, in a triangle, suppose this is point P, this is point C and this is point Q. So in triangle, PCQ, R1, angle R1 is equal to angle R2, because angle in front of equal sides are equal. This is radius, this is also radius. So opposite to this side, angle R2 is present, and opposite to this side, angle R1 is present. And these two sides are equal. So opposite angle should be equal. Opposite to this side, this angle is present, and opposite to this side, this angle is present. This side and this side both are equal. Hence this angle and this angle should be equal, because opposite to equal side in a triangle, angles are equal. R2 will be equal to 30 degree. So now we know R2. Now once more use Snell's law at point 2. to find angle of emergence. So third, refraction at Q, point Q. So I'm going from this side to this. So refractive index of this mu into sine R2 is equal to refractive index of air into sine E. So this is root 3 into sine R2 is 30 degree is 1 into sine E. So root 3 into 1 by 2 sine E. So here sine E is root 3 by 2. So E is 60 degree. So E is 60 degree. Now deviation here, it is angle of incidence greater than angle of refraction. So I minus R1. So angle of deviation, total deviation will be sum of deviation at first place plus deviation at second point. Deviation at first point is 60 minus 30. 60 is angle of incidence, 30 is R1 plus here E minus R2 because this is greater than this. So E is 60 minus R2 is 30. So it is 30 degree plus 30 degree. So 60 degree. So total deviation is 60 degree and it is clockwise. Total deviation is 60 degree clockwise. So that is the answer. One more example. Suppose this is water. This is water and here there is a concave mirror. Focal length of mirror is 20 centimeter that is given. And suppose this distance is 36 centimeter. If parallel beam of light is incident on water surface like this normally, like this, so it goes undeviated and get incident on mirror. So these rays are parallel. So we know one parallel ray incident on mirror, after reflection they meet at the focus. So let this is principal axis, this is the principal axis, and suppose this is focus. So after reflection the ray will pass through focus like this. Similarly after reflection it will pass through focus like this. So image going to be formed here. This is image formed by mirror. Now this ray is moving out of water. So when it is refracted here, it will go away from normal. Similarly, when it will be refracted, it will go away from normal. So it appears that these rays coming from here. So image of this will be formed here. So this is final image. So if observer is in air, it is going to see this image, not this image, because rays from here appears to be coming from here. So this distance will be apparent height and this is the real height. So if parallel rays fall on mirror, then it will converge at focus, and after converging the ray will go, it will again come out of water, so there will be refraction. So the rays which is actually going from here appears to be coming from here to an observer which is looking on this ray from here. So this is the position of final image. So we have to find what is distance of final image from the water surface. Find distance of final image from water surface. When viewed from air. From air. This we have to solve. So first, as you know, object for mirror is at infinity, so image by mirror will be on the focus. So this distance will be 20 centimeter and total distance is 36 centimeter. So this is 20. So if this is 20 centimeter, then this should be 16 centimeter. So real height of this image is 16 centimeter. And we going to see image of this image. So actual में this image going to be here for an observer who looking this ray from outside. So apparent height upon real height is equal to refractive index of observer medium upon refractive index of object. So A we have to find, real is 16 is equal to observer is in air and object, this is now object that is in water. So A will be (12 centimeter). So the final image is 12 centimeter below the surface of water. So this is our answer. Final image is 12 centimeter below the surface of water. But what is depth of image formed by mirror? This is the depth of image formed by mirror, actual depth. But when it is observed from air, it appears to be here. So when object is in denser medium and viewed from rarer medium, actual depth is not visible. It is apparent depth. So it appears to be above than its actual position. That is the reason why when you see bottom of swimming pool from outside, it appears to be lifted. So sometime feeling may come that the swimming pool is not very deep, but actually it may be deeper than what you see from outside. So one more question on refraction, and this question a bit difficult, so try to understand the question first. Suppose this is a sphere of a transparent material whose refractive index is √3. This is centered. This you may assume as principal axis, center. Suppose an incident ray strike a sphere at this point. if you connect this point with center, this will be normal. So this is normal, and it is given that angle of incidence is 60 degree. It is given, and this height is also given. It is root 3 r by 2. R is the radius of the sphere, that is given. Let this is point A. Now it will not go like this. After refraction, as it is going in denser medium, so it moved like this. So this is a refracted ray. Refracted ray. Now question is, what is length of a refracted ray in a sphere? Second, distance between the point where a refracted ray meet principal axis, and center of a sphere. Distance between the point where a refracted ray meets principal axis and center of sphere, this we have to find. And what is length of refracted ray in sphere, that we have to find. So let us see how to solve this question. Suppose this angle be R, angle of refraction. These two rays are parallel, that is given. So if this angle is 60 degree, this angle will also be equal to 60 degree corresponding angle. Now if I apply Snell's law here, I can find R. So applying Snell's law, at this point. So it is a refractive index of air, that is 1 into sine 60 degree. This angle is equal to refractive index of this medium, that is root 3 into sine r. So it is root 3 by 2 is equal to root 3 into sine r. So sine r is 1 by 2, hence r is 30 degree. Now we know this angle is 30 degree. 30 degree. Let's extend this. Suppose it meet here. I don't know where this going to meet. If it meet here, let this point be Q. So distance between this point and center is this CQ. This we have to find. Now see, if I draw perpendicular from this point on this principal axis, this is 60 degree, this is 90 degree, so this will be 30 degree. So let this point be M. Now in triangle AMQ, this is a right angle triangle. This whole angle is 60 degree. So this is base, this is perpendicular, and this is hypotenuse. Right? This is base, this is perpendicular, and this is hypotenuse. So first we are going to find hypotenuse, because this is length of refracted ray in the sphere. Or first find CQ, because it may be, if it goes here, then this length we have to add. So let's find CQ first. So in order to find CQ, I am taking this right angle triangle, this right angle triangle. So in right angle triangle AMQ, tan 60 degree, tan 60 degree, this whole is 60, perpendicular, that is QM upon base AM. So QM upon AM, QM upon AM, AM is this, root 3 R by 2. So it is root 3 is equal to QM into 2 divided by root 3R. So QM is 3R by 2. So now this is known to us, QM is known to us. What is this distance? This is R and this is 60 degree. So this will be R cos 60, that is R by 2. So CM is R by 2. So this we know. So QM is CM plus CQ. So 3R by 2 is equal to R by 2 plus CQ. So CQ will be equal to 3 by 2R minus R by 2. So it is R. So CQ is R. It means this refracted ray will meet principal axis here, because this distance is R. So Q point will be somewhere here. Now you know this is the length of refracted ray in the sphere, and this now we can find, because I know this angle, that is 60 degree. This angle is 60 degree. This is base, this is hypotenuse. So in triangle AMQ, cos 60 is equal to AM base upon hypotenuse AQ. So it is 1 by 2 is equal to AM is root 3 R by 2 AQ. 2 cancel. So AQ is root 3 R, and AQ is length of refracted ray in the sphere. AQ is length of refracted ray in the sphere. So this is what asked. What is length of refracted ray in the sphere? So this answer is root 3R. What is distance between point where a refracted ray meet principal axis and center of the sphere are. So these are the two answers.